addressing modes. So in this 8086 addressing modes, the instructions will be assembly language programming. Instructions will be written in assembly language programming. So what is this assembly language programming is? So we already discussed this format. So it's like a move which will be considered as a mnemonics, and you'll be represented CX comma 0004. So in this path is indicating as a source, and the other one will be indicating as a destination. So means what, this whatever it is present here has been moved to a register CX. So this is what an assembly language program. It's like we'll be calling this language as a middle level language, where some part of the instructions we can understand and some part a system can understand. Like if it is a move, we know that it is something moving. It's from one data to other data. There is a move instruction that we can understand, but internally this assembly language even has to be converted to a machine language to zeros and ones. Based on that, a system can understand this is a mnemonic code for a move operation. So here, so compiler converts a high level language into machine level language. So assembler converts what, the assembly language programming into a machine language. So machine language instruction, it only contains zeros and ones. So assembly language contains a mnemonics. So means what, like this, that some part means like we'll be representing like move, will be representing as move r1 comma r2. So this r1 comma r2 will be represented inside the content of that in binary 1011 like that. But this move is some, we can understand that moving the content from these registers. So again this assembly language has to be converted back to a machine language. So this is about the programming in this is written in an assembly language. So here let me show with an instructions. So we have an instruction. So we'll be going again to unit 1, where we have an instruction. So in this instruction we'll be having two types. One is an opcode used for specifying the operation and the operand. So one is an opcode, what operation it is performing, and the other one is an operand. Okay, so this is your instruction. So what is this is what we are doing actually is we are studying about an addressing modes. So what are addressing modes we'll be discussing. So before that, so instruction we'll be discussing. Instruction is one field, it contains an operation code, and the other field it contains an operands. It will not be one, so it depends upon what type of instruction formats you are using again. So operands, an instruction contains an opcode and one or more operand. Mostly instructions contain only one or two operand. So the instruction size varies from 1 to 6 bytes. So these are some assembly language instructions, and this is a format where if this is an instruction it is given, so this will become your source. From whatever the content which is present in BX will be moved to AX register, means if AX register previously if it was 10, the contents will be removed 10, and whatever the value which is present in BX will be copied inside that, means 20. So this 20 will be going and it will be overridden, and you will be getting the value as 20 here. Okay, so let me start an addressing mode. So before going for that, so first anyone answer, we already discussed, what is an addressing mode actually. Addressing modes are what? What are addressing modes, man? We'll be having different types of addressing modes like register addressing, register indirect, memory addressing. Okay. The way
Types,
in,
ma'am.
I'm not asking types. What are addressing modes I'm asking? Okay. So the way in which the operands are specified. Okay. The way in which an operands are specified are said to be an addressing modes. Okay. So in this you need to access an operand, right?
అది కూడా
So
ఆన్ చేయి.
what happened? Am I audible?
Yes, ma'am. Yes, ma'am.
Okay. So the way in which operands are specified is addressing modes. Okay. So that there are different ways. So if you go to that, if you go to this, if you go to that location, the address will be specified here. If you go to this address, you will be getting an operand. Or else if you go, address will be specified here. If you go to that location, you will be getting one more address. If you go to this address, you will be getting an operand. So there are different modes. So addressing modes are nothing but there are different ways in which an operands are specified. So based on which there will be different types of addressing modes. So we'll be discussing one by one based on 8086 addressing modes. Okay. So here there are 7 types of data addressing modes we'll be discussing. So one is immediate, direct addressing mode, register addressing mode, register indirect addressing mode, register relevant addressing mode, register index addressing mode, relevant based indexing addressing mode. So we'll be starting one by one. So before only I'm saying this, the concept is same that we discussed in general addressing modes, but what we are adding here is we need to know if it is an addressing modes, how to calculate the physical address. Okay. So in immediate addressing mode, what does this immediate addressing mode means? Inside an instruction and data, one of the operand is mentioned directly. Data is available as part of the instruction. So you're not going anywhere for getting the data. Okay. So for getting the data, for example, the data which you want to search is available in the instruction itself. So this is your data is available in the instruction itself. So you're not going for fetching the data to memory location, or you're not going to register for getting the operand. So operand is available inside the instruction itself, is immediate addressing mode. Okay. So one more is, if it is mentioned, it is an instruction. In this instruction, you will be having an opcode, and you will be having, if it is immediate, operand will be available here. And you should know if it is 8086, what will be the size of this operand, how much size it is mentioned. So for that, you should know 4 general purpose registers. Can anyone, what are those 4 general purpose registers? 4 general purpose registers. What are 4 general purpose registers in 8086? 4,
Ma'am, AX, BX, CX, and DX.
yes, AX, BX, CX, DX. Okay, so we can access either as a 16 bits, or we can either access either as an 8 bit. Okay, so here you will be having general purpose registers with AX as AH, AL, and BX as BH, VL, CX as CH, CL, DX as DH, DL. Means what? Here you will be mentioning as move AL comma 0 to H indicates what? So this is the AL indicates lower order. It is totally, this is 16 bits. So in the 16 bits, lower order is from 0 to 7, 8 to 16 is higher order. Okay. So if it is mentioned move AL comma 0 to H, this is your immediate. One of the operand is mentioned directly. So this is your source, this is your destination. So 02 indicates this is the data which is available in the instruction itself. It is moving to register AL. So now AL will be 02. Now AL will be 02. Now such in this case, if it is AX, then it is 16 bits. So whenever you are moving, you try to think about the size. So it is hexadecimal. So it is, if it is 02 means it will be 8 bits. So 8 bits data, you are moving into 8 bits AL register. AL is of 8 bits, AH is of 8 bits. Now when we want to move 16-bit data, that it is not preferable to select AH or AL. It is preferable to select AX, which is of 16 bits. So in this case, I can go for 1234H, where the 16 bits will be moved to this AX. In this, I want an answer. If I want to move 1234H in AX, but internally AX is represented in this way, right? AX will be represented as AH and AL. Now tell me, 1, 2 will be placed in which, and 3, 4 will be moved to which location in AX? It is clearly mentioned higher
1 2
order.
in AH and 3 4 in AL.
Yes. So 1, 2 will be placed in AH. Why? Because these are higher order, and 3, 4 are lower order. So will be placed in in AL, lower order. Okay. So in this way, it will be working internally based on this 1, 2 and 3, 4. And even if I go and explain internally, again you will be having this as a address. Why? Because we are discussing about addressing modes. So if I consider about this address, if I mention, instead of this, if I mention that 1, 2 has to be placed in AX, means I should represent it has to be placed in even address. It has to be placed in even address, means this one will be placed, you will be representing an address, then only it goes to that particular location, right? So internally we have studied about two bankings. One is even banking and odd banking. So based on this, it goes to that particular address and it places the data in this lower order 34. Okay, so that we'll be discussing later, but until here it is, I will stop. Okay, so this is an example where move CL comma 03H. So this is your immediate data. So 03 is an 8-bit immediate source operand. So CL is your destination operand. So this data has to be moved to CL, which is immediate mode. Okay. Now coming to the second example that I explained here. So here in this case, here the size of the general purpose register we have selected as AX, and this is your immediate data. Okay, this data and the data which is available in AX both has to be added and the result will be stored back in AX. Okay, so whatever the data which is there in the immediate instruction, which is 0225, and the data which is there in AX, let us suppose the data is 0001, which is hexa, both are hexa. So both will be performed in addition and the result will be stored back again in AX. Okay, this is about an immediate mode. So in this operand will be the operand data will be available inside an instruction itself. This is one more example with why I have shown this is for every example, for every representation of addressing modes, you have to explain that. You have to take one example and you should show the diagrammatical way. Okay, so this is your memory, where this is your AL. So AL, what it is doing? So this is moving to AL, means what? From this memory, it is moving and it is placing in AL register. Whereas here, this is your memory instructions. So from this, it will be placed in this AL and this in AH. This in AH. This is about the diagrammatical way to represent. Next is about register addressing mode. Okay, so in register addressing mode, so both operands are in register, no memory access, so we are not accessing the memory for getting an operand. And when we go for register addressing mode, there are some limitations for that. Is limited, we have a limited number of registers. Address field is needed and very small address field is needed to address registers, and these are the registers that we are using. So what are these registers? Segment registers. So extra segment, stack segment, core segment and data segment. These are the corresponding addresses. Okay, so let me show with an example. See here. So register addressing mode. So in this it is mentioned as 16-bit register instruction. Okay, so here whatever the content which we have in AX will be moved inside BX will be moved inside AX. Okay. So what is this register addressing mode? So wherever this is the general one that we discussed in the first unit. So this is about 8086 architecture. So 16-bit register addressing mode where the content of BX will be moved to AX. So according to this, what can you draw the diagram is? Let us consider this is your general purpose register where you have an AX as 10 and 20. Okay, and BX you have the data as 30, 40. Okay, so when this instruction is executed, this will be copied into BX contents will be copied into AX. So this will be replaced with 30 and 40. Okay, so you have to show with a diagrammatical way. Next is adding the contents in whatever that we have in destination index with general purpose register AX. So this is about 16. This is about 16 bits. When we are representing with 8-bit register instruction, so we need to represent either a lower order or either a higher order bits. Okay, so whenever you are going, you don't take the target as 8 bits and 16 bits. Why? Because see here, so if I say move AL comma BX, let us suppose, it is not possible. Why? Because the target that you destination register that you have selected is 8 bits, but you want to copy this, the size here is 16 bits. So this size type of an instructions will not be supported and completely it is wrong. Why? Because this is of 16 bits, you want to move inside as 8-bit register. So this should not. So that's the reason clearly it is mentioned an example. 16-bit register instruction and this is 8-bit register instruction. Okay, so next coming to see here, this is one more example where move AX comma CX, so it moves the contents which are present inside the CX into AX. Okay, so next coming to this, we have done with 2 registers. What are those 2 registers? Immediate addressing mode and register addressing mode. So till now we have not started with calculation of physical address. Why? Because in immediate there is no need of going from memory location. Inside an instruction itself you will be having a data, so you will be moving to the targeted register. And coming to register indirect mode, through you both the operands are registers, and you whenever you are doing performing, we need to think about whether the 2 registers are of same size. Is it 16, 16? Or else if this is 8 or 8. So think about that and we can perform a move instructions or ALU operations. We can do ALU operation. Coming to direct memory addressing mode. So in direct memory addressing mode, so concentrate here, you should concentrate more. So in direct addressing mode, first anyone tell me about what we have done in direct addressing mode in general addressing mode concepts. It is mentioned as move R1 comma, you will be having an address here, right? So let us consider this address is 200. So what happens in direct memory address? If you go to the 200, you will be getting a
Operand.
You will be getting an operand, and this operand has to be moved inside R1. This is the general approach where memory we have a 2 addressing modes. One is memory direct addressing mode, memory indirect addressing mode. So we are discussing about memory direct addressing mode. In this, if you have an address here, if you go to that address, you will be getting an operand. So this operand has to be moved inside a register R1. This is a general approach. And now see here, whatever the instruction, this is the instruction, let us suppose it is mentioned as move CL comma 4321H. Inside the instruction which is given is an offset register. is offset address. See here, direct memory addressing mode. In this mode, the address of operand is directly specified in the instruction, but it will be mentioned as the address is specified in the instruction. But what address is that? Is an offset address. Here, only the offset address is specified in this. Specified the segment being indicated by the instruction. What segment? Okay, like the offset address is specified. So this is your offset address. Now I want an answer, ma'am. So here you have an offset. You have an offset address. You have an offset address. Now I need to find out the physical address. This is a question. Okay. So now I need to find out the physical address. So for that physical address, what we need to do, ma'am? So for that physical address, we know the formula. So the formula is base segment registers into 10H plus offset. Okay, but offset will be mentioned inside the instruction. Okay, so based on the type of offset, we need to select the corresponding segment register and we need to perform. So in this case, this instruction moves data from location 4321H into data segment into CL. So for that, we need to calculate, this is the address. So, but physical, internally, we need to calculate the physical address. So this is a physical address. So this is the instruction. So by default, listen all of you, default, we need to select a data segment. Okay. So here, this is a offset register. So which is offset register, which is 4321. And data segment will be given in the question. So it is given as assume data segment equals to 5000H. Okay. Now find out the physical address. Now tell me which segment we need to do left shift operation. Is it a data segment or is it an offset segment, offset register? Which one we are performing a left shift operation, ma'am?
Data segment, ma'am.
Yes, we need to perform a data segment left shift operation. So here we are assuming a data segment as 5000. So for this, if you do left shift operation or if you multiply with the 10, you will be getting 50,000. So here you will be getting 50,000. After multiplying this with 10, this is the result. Plus, if you do the offset register, which it is mentioned in the, which is mentioned here, if you add, then you will be getting an offset register. Okay, so this offset register and the data segment which you add, if you add, then you will be getting the address, which is nothing but an effective address. So if you go to that effective address, you will be getting an operand. So if you go to the memory location 54321, then you will be getting an operand. So whatever the operand which is present there, it has to be moved to CL register. CL register. Is it clear or should I repeat once again? What, ma? Should I repeat once again?
Clear, ma'am.
Others, please, ma, respond. Okay. Here. So this is about direct memory addressing mode. So one more example I have considered so that you can understand even more clearly with a diagram. So once again I'm saying, whenever you are representing any addressing mode, you try to take instruction with an example, with the example that you have represented, show with a diagrammatical way. Okay. So in this it is mentioned as move AL comma 110. This is your what? This is not the data. And just now I said no, it should be equal. It should be equal when this is data, but this is not the data, it is address. How can you identify that this is data or addresses? It is mentioned in parenthesis. So here square brackets, that indicates that it is an address. Okay. So if it is an address, which address is this? An offset address. Okay. So given an offset address, we need to calculate a physical address. So for that, we should by default we have to consider as a data segment. Okay, so data segment we need to assume if it is not given in the question, maximum of the time it will be given in the question. So data segment, it is mentioned as 2000 H. So this is offset register. So for this, if you need to multiply with 10 H, so that you will be getting 20,000 H. So 20,000 H, and the offset which is mentioned in the instruction 1064. So 1064 we need to add, so that you will be getting an effective address. So you got an effective address. So this is the address. So you need to go to this address. So if you go to this address, you will be getting an operand. This has to be moved to AL. This has to be moved to AL. Okay. So this is about direct addressing mode. So whenever you are representing with a diagram, this is what, mark? Can anyone? What is this? This part is what? It is a memory, and everyone knows that 8086 memory will be of 4 segments: core segment, data segment, stack segment, extra segment. So this is your core segment. From this you are getting an offset. Okay, from this you are getting an offset, and using this you are able to identify a physical address. Then whatever the data which is there in this physical address, the data you are moving inside a register called AL. Now I will be giving one example. Based on that, tell me, move. See here, let me explain. This is one more different. It is mentioned as, see here, it is mentioned, if you go to that address. Now, anyone please answer. Data bits will be how many, ma, in 8086 data? Data bits. How many data bits, ma, do we have? 8086.
16, ma'am.
16. But can you read in a single cycle 16? How it is implemented internally based on memory banking, right? So you can access 16 at a time. So that, but it is internally it is represented as 88. Okay, internally it is represented as 88 based on the address. You can give the same address, and whatever the 8-bit is there, and whatever the 8-bit which is present here, we can access 16 bits if you want, or else you can access by activating only this memory chip, so that we can access only these 8 bits. This we have studied, right? Internally the memory will be having two bankings. So this one will be of 8 bits, this one will be of 8 bits. So in a one cycle you can access 8, 16 at a time if both are active, or we can access one at a time. Okay, so here what is happening in this case is the address that you are calculating, it is only for one. It's like you'll be representing like this, ma, AL, AH, BL, BH, like based on the addressing which we have specified. Okay, so in this case, what it is mentioned as, for the previous case it is mentioned as AL. Okay, means if you go to that location, if you need to calculate the physical address, if you go to that location, you will be getting 8 bits. But if you want, if it is mentioned as AX, then the above one has to be accessed, the above one. So how is that possible? Let me show with an example. See here, move CX, 0400. Okay, so if it is mentioned as 0400, this is your offset register. Try to concentrate, ma. This is your offset register, and DS it is mentioned as 3050. Okay, for this DS you need to do what? You need to do into 10, so that you will be getting 30500 plus this one, so that you will be getting what? The effective address 30540. Okay, so this is where you will be getting CL content. Okay, so let me show with an example. So here you will be having CX with CL and CH. Which one is even? Which one is odd, ma? CL is even or CH is even?
CL is even, ma'am.
Okay, CL is even. So this one is even. This one is odd. Okay, that means I don't want to show in this way. I want to show in a memory way in sequence. So let us consider the address that we calculated is 30540. Okay, this is. If you go to this address, okay, you will be getting 8 bits, which is CL. So if you want CH also, this has to be incremented so that you will be pointing to 30541. This one. In this you will be getting CH. Either way you can represent, either in this way or either in this way. But 8 bits both has to be combined so that you will be getting a 16 bits so that you can access. So for that is a reason that what after calculating we got an address, and in this address you will be having CL, and it is mentioned as CX, means both has to be placed, both has to be moved. So for that it is incremented. So you will be getting 30541 so that you can access CH. That depends upon the destination register which is given. So let us modify the instruction. Move CL comma 0400. Okay, then simply this offset plus the data segment both has to add data segment content into 10, the result and this result both has to add, then you will be getting some physical address. If you go to that address you will be getting an 8 bit. That 8 bit you can move to CL, it's enough. But as it is mentioned CX, so what we need to do, this whatever that we calculated will be lower order. So this is CL. So in order to get CH, the physical address has to be incremented so that you will be getting 30541. So that the content which is present here called 20 will be moved so that the 10 which is there in this address and 20 which is there in this address will be moved so that the lower order content 10 will be placed here and 20 will be placed here. Finally you will be getting the data as 2010H. 2010H. Okay, is it clear, ma'am? Or should I repeat once again? Fast.
Clear, ma'am.
Others, please respond.
Yes,
Clear,
ma'am.
ma'am.
Clear, ma'am.
Okay. Clear, ma'am. Okay, ma'am. Thank you. So now let me start with indirect. Register-based indirect addressing mode. So register-based indirect, this I will continue in the next class, ma'am. So let me revise. So we started with 8086 addressing modes. So in that we have started with immediate addressing mode. In this immediate addressing mode, inside the instruction, the operand will be residing and you can use that operand. Okay, the example is directly you are using an operand. 03 is the immediate data. We are moving inside, we are performing according to our application, we are performing a move. So this is your immediate data, we are moving inside CL. Okay, this is about add. This is your immediate data which is moving inside an AX, but concentrate on which one is 8 bit, which one is 16 bit. And coming to register addressing mode, so you'll be having two registers. So these are the two registers, AX, BX, and the AX contents will be copied inside will be moved inside a BX. And addition, so both will be added and the result will be stored in AX. And coming to direct addressing mode, for the previous two, register addressing and immediate addressing, we are not calculating physical address. Whereas in direct addressing mode, inside the instruction, whatever the address is there, this is your offset address. So if it is not mentioned what our offset address is, for let us suppose in the question, it will be mentioned that the offset address which is present in the instruction is DP. Then which segment will you prefer, ma'am? It is mentioned in the question, the offset address which is
Stack segment, ma'am.
Yes, so we need to go for stack segment. If it is not mentioned the offset register what we are using here, then by default you can go for the data segment. So that is the reason that we don't know which offset register it is using. So by default we are selecting a data segment, and in the question also it will be given assume the data segment as 5000. So we need to calculate the actual physical address for that. So we are calculating data segment into 10H plus the address which is mentioned in the instruction called an offset register. And coming to addressing modes, you need to know about the size. So whenever you are going to particular address, if you calculate the physical address, you are getting only 8 bits. Okay, but when you are moving to the targeted destination address, if it is 16 bits, then the calculated physical address plus 1 if you do, then you can go for the higher order address also. In this case this one has to be moved to this, but whatever the calculated physical address is there, if you go to that address you will be getting 8 bits, so that can be moved in CL. So if you want CH also, this calculated address plus 1 means we'll be moving up so that you can get CH also. Let me stop.